Okay, let's have a look at Newton's second law. The first law was the law of inertia. The second law is the only one of the three that can be written as an equation. And what it looks like is the net force, and it's always the net force, right? The sum of all forces acting on the object is equal to its mass, a measure of its inertia, times its change in motion or acceleration. Okay, so that is the second law. So net force and mass are directly proportional. Net force and acceleration are directly proportional. Mass and acceleration are inversely proportional. We'll touch upon that again in a second. So Newton's second law states that the acceleration an object experiences depends on how much net force is placed on that object. The more net force is applied, the greater the acceleration. So this is what we call mathematically a direct relationship. The more net force, the greater the acceleration. The variables always change in the same direction. The less net force, the less the acceleration. The acceleration of an object also depends on the mass. The greater the mass, the harder it is to accelerate the object. Okay, so here is an inverse relationship. Okay, so if this is direct, where the variables change together, this is inverse, where the variables change opposite of each other. Okay, so here, when the mass increases, the acceleration decreases, provided the net force stays the same. An object accelerates in the same direction as the net force. Just look at the formula, F net equals ma. Mass is a scalar quantity, so the direction comes from the vector quantity acceleration and must be the same as the direction of the vector quantity force. So the acceleration is always in the direction of the net force. Always, 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 right? They always point the same way. And in equation form, Discovery Education gives us a little microscopic view there of what that looks like. Notice how they denote, I'll just draw a little picture here. They denote a vector quantity with a little arrow that goes over the acceleration. You can see boldface type, you can see a little arrow, you can see a little line over the top. It depends on the textbook, they're all a little bit different. So an example of Newton's second law is when a baseball player hits a baseball. A force is applied to the ball which causes the ball to accelerate in the direction of the force. The acceleration produced depends on the net force and the mass of the baseball. So the more net force there is, the greater the acceleration, and the lower the mass, the greater the acceleration. Notice how that first relationship was a direct one, and the second one between acceleration and mass was an inverse relationship. Okay, I hope that makes the second law a little bit clearer.